We have learned how to combine experiments. Now we'll have a couple of very important examples. One of them is Bernoulli, the other one is Poisson point process. In Bernoulli trials is when you repeat one experiment which the outcome is binary. Of course, this is important because any event could be considered as binary, either this event happening or not. So if you repeat one experiment, let's say n times in n independent times, okay, and this event A could happen in some of them or it could not happen. So either you have A happening or you have A bar happening in each individual experiment. So each time you will have a binary outcome, either A or A bar. So we want to know what is the probability that K out of N we are successfully having A. So Bernoulli experiment is that you repeat over a probability space n times, and then you are interested to have a successful event A happening with probability of A being P and probability of A bar being 1 minus P. If you repeat this independently n times, so this independence is very important. So and then the combined experiment, so we want to calculate, so this is your L is equal to, because you repeat n times, you will get L to the power of n, and your overall F will become the previous F to the power of Cartesian product of F n times together, and your probability measure can be calculated. So in that case, if we denote probability that out of n experiment, k of them you're successful, we say that probability in k is k chooses n, p to the power of k, and q to the power of n minus k times this one. This is because if you have n slot, like a slot number 1, a slot number 2, and you have a slot number n. Here you have either A in the first place or you have a naught. So either you get A or you get A bar. Here you get A or A bar, etc. So it's like you have, if you put for A you put 1 and for A bar you put 0, it's like you have a number which has n bits. It has n digits, and the first digit represent if in the first experiment you had A or not. So the total number of possible outcomes is 2 to the power of n, obviously, because L is equal to 2, and 2 to the power of L to the power of n is equal to the number of elements of this one is 2 to the power of L to the power of n, and this is equal to 2 to the power of 2 to the power of n. Now, how many of these binary strings have k of them is equal to 1? So obviously, if you have k1s, so if you have k1s and n minus k zeros, so you want to put these ones in n different slots. So the first, so you have, let's say you have k1s, okay, so you could put it here or you could put it here and so on. So the first k, first n, you have n possibility. Once you remove it, your number of slots will become n minus 1, so you will have n minus 1 option, etc. And the last one will have n minus k possibilities, okay? So, but then all permutations of these ones you have, they're calculated multiple times, so you have to divide these by, so n minus k and n minus 1. So k factorial. So this is this number. So this is this number. So this is called a Bernoulli distribution is represent the probability of ones in n times repeat. So as exercise, try to either justify or prove these for yourself.